Hello, hello, hello. How we doing? I really miss you guys. Hope you guys are hanging in there. We have an assignment coming up today that's gonna be like a review of all the exponential growth and exponential decay problems we've been working on. And it's like 3-page review. And here it is. You should have it. It's a PDF document in the same folder that this video is in. And I printed mine out, and I looked at a couple of problems. I thought we better do some examples that are going to be similar to some of these problems, so you guys will have something to kind of jog your memory about how to do some of these things. Now, one thing you have to keep in mind is we're going to need our calculator. If you don't have a calculator, most of the work we can do can be done on your phone's calculator just as well. But if you really need a graphing calculator, one of the best ones to go to is Desmos, and that's D-E-S-M-O-S, Desmos. And it's free, and it's online, and you can do it on your phone. I think there's a Desmos app you can get as well. Really nice graphing calculator. And then there's some other free ones out there too. Please don't spend any money to buy a graphing calculator if you don't have one already, because we'll be back in school eventually, and you can get by on using the apps on your phone or Desmos. All right. Now, we're going to do a few examples, like I said a minute ago, that are similar to the problems on the review guide or the review pack. The first one, we'll look at an example that is similar to the first few problems. And they're all about like exponential growth with a deposit in a bank account or a savings account. And so I have this example behind me that says, interest rate's gonna be 5%, and it's gonna be 3 years, and we're gonna end up with $8,000. First, I wanna write an equation. Well, it doesn't come out and say it, but in this particular problem, it's a compounded continuously problem, And remember, and I think I wrote the equation on the review guide. Yeah, I did. Remember, we wanna use A equals P e to the RT, where P is the amount of money you start with, R is the interest rate as a decimal, T is the time in years, and A is the amount of money we ended up with. So to write our equation, we're going to say, for this one, we're going to say 8,000, because we ended up with 8,000. 8,000, I'll put it right there, equals P, and that's, we don't know. We don't know what that one is, because it's asking, what did we start with? We don't know. So we're going to say equals P, and then e to the RT. R is 5%. I got to change 5% to a decimal. How do I change 5% to a decimal? Boom, boom. Move that decimal over 2 places, and we get 0.05. 0.05 times T, and T is time, and time is 3 years. So that would be my first equation. 8,000 equals PE to the 0.05 times 3. And then it says how much, we got to figure out what we start with. So we got to figure this out. We got to solve this equation for P. And this is kind of a pain to solve this equation for P. But we're going to multiply these two together. We're going to multiply 0.05 times 3, and that's going to be 0.15. And so I can kind of like get rid of this and write there 0.15. And then I've got to figure out what e to the 0.15 is on my calculator. So I'm going to whip out my calculator, my trusty dusty graphing calculator, and I'm going to do second e to the 0.15, and I get 1.16. So now my new equation, if I keep on working with this, I got 8,000 equals P times 1.16. And we're trying to solve for P, and so we're going to divide both sides by this 1.16. And then we divide that on the calculator again. I can't do that in my head. I'm going to do 8,000 divided by 1.16. And we get $6,896.55. $6,896.55. Now, the problem on the review guide says round to the nearest dollar. So that's what we'll do here. We round that to the nearest dollar, we get $6,897. So reviewing how we did that, we got the equation, A equals PE to the RT, and we put in what we knew. We knew the rate was 0.05, we knew the time was 3, and we knew that the amount that we ended up with was 8,000. So we got 8,000 equals PE to the 0.053, multiplied those together, 0.15, figured out what E to the 0.15 was, which is 1.16, divided both sides by that 1.16, and we got the amount of money we started with. Now, there's a follow-up question written down here. It says, how much after 6 years? And I got some scratch paper over here. We're going to work that one out. How much after 6 years? Well, I'm going to go back to my original equation, which is A equals PE to the RT. So how much after 6 years? That would be A. This is going to be A. How much after 6 years? That's the unknown. So when we say A, I don't know what that is. But now I know the principle. I know what it started with. We had to figure that out. We started with $6,897. So $6,897 times E to the R, that's 0.05. T, and T this time, T is right there. T is 6 years. So T is 6. So they put a 6 right there. Okay, now I just got to do some math. I just got to do all that. I got to crank that out on my calculator. You know what? I'm going to do this in my head. 0.05 times 6, that's 0.30. Okay? So now on my calculator, I'm just going to plug in exactly what that says. 6,897 times second E to the 0.30. Enter. And oops, my eyes are playing tricks on me. I didn't hit E, I hit 10 by mistake. So 6,897, second function E, got it. I got it that time. 0.30, and I got $9,309.98. $9,309.98. And again, it says the problem on the worksheet says to round this to the nearest dollar. And so I'm going to say $9,310 would be the answer. That's how much we have after 6 years. Okay. This example, or this couple examples, is trying to get you to work through numbers 1 through 8 on the review guide. Okay, so you can stop the video now. You can pause the video if you want, and you can do those problems, or you can watch the whole video at once. I'm going to change my poster boards now. Take this one down, and we're going to substitute in my examples for numbers 9 and 10. All right, let's see if I can tape this guy up there. That's not good. So it doesn't come down. Okay, it didn't work. Let me get another piece of tape. Here we go. Got a little extra right here. Put this bad boy up there. Okay, and get my new scratch work up there. Just in case, and I'm not sure I'm going to need scratch work, but I might need room for scratch. We'll see. Hopefully that'll stick. All right. So now we're looking at numbers 9 and 10. Number 9 and 10, they are talking about exponential decay, I think. Well, at least number 9 is definitely exponential decay. This is really going for number 9, really. In this example, we have an element like iodine or something like that, and it's decaying at 22% per minute. And we started with 1,527 grams. How much is left after 15 minutes? All right. Well, first thing that we want to do is write an equation. And we're going to use y. We're going to use y as the amount of the element we have left, and x will be time. X will be time, and y will be the amount of element we have left. So if we say y equals the amount we started with, which is 1,527, times 1 minus, how much is it decay per minute? 22%. So that's 0.22 raised to the number of minutes. X. Ta-da! And that would be how we figure out how much iodine we have left, or how much of the element we have left after a certain amount of time. So now after 15 minutes, we're actually going to answer the question. Now after 15 minutes, we're going to take this, and that's going to go in right there for time. X goes right in there. 15 goes right in there for the X. And now we say Y equals 1,527 times, I'm going to do 1 minus 0.22, that's 0.78 raised to the 15th. Do that on the old calculator. And it's going to be pretty small number, not a very big number. 1527 times 0.78 to the 15th power. We get, that's not right. I hit the wrong button there. Let me try that again. 1527 times 0.78 to the 15th. And this time I got 36.75. 36.75 grams. That's how we do one like number 9. Number 10, that was more like back to number 1. That's very similar to number 1. Yeah, it's almost exactly the same. Okay, the next 2 examples I have are supposed to be like numbers 11 and 12. Okay, these are problems that we did a long time ago, and you might forget how to do these. One of the videos, though, that you watched was supposed to try and remind you how to do these. So these are called exponential equations, and the easiest way to do it is when you can rewrite one side or the other using the same base as the other side. So it looks like the 4, I can change that 4 to 2 squared. If I change that 4 to 2 squared, I got 2 to the 3x equals 2 squared to the x plus 1. Okay? Now this is where it gets a little tricky, I'm going to say that 2 to the x plus 1, 2 squared to the x plus 1. I'm going to take this 2 and I'm going to multiply it by the x plus 1. So I got 2 to the 3x equals 2. Now this is going to distribute 2x plus 2. All right, now I'm going to go over to my scratch work side. And I have 2 to the 3x equals 2 to the 2x plus 2. All right, so I want to say, okay, the bases are the same, so now I can say the exponents are equal. So I'm going to write a new equation that says that equals that. 3x equals 2x plus 2. And now I just subtract 2x from both sides, and we got x equals 2. That's the answer. That's how you do that. The key was to make the bases the same and set the exponents equal. Now, number 4, this is a little trickier because you got that upside down, got that fraction. But I'm going to change 7 to 1/7 over here. And when I change 7 to 1/7, that just needs a negative exponent. So I'm going to take this exponent and change it from negative 2x to just 2x. So now I got 1/7 to the 2x equals 1/7 to the 3x minus 1. Now we can do the same little trick we just did. We set this equal to this because our bases are the same. So our new equation that we're going to solve is 2x equals 3x minus 1. And then if we try and solve that, I'm going to do that over here on scratch work. We got 2x equals 3x minus 1. And if we solve that, we're going to subtract 3x from both sides. If we do that, we got negative x over here equals negative 1. So that would mean x equals 1. So the key to those last 2 problems, the key was getting the bases the same. Rewriting the base so that you have the same base on either side. Then you can set the exponents equal to each other. All right, now I didn't do any examples for the last few problems because they were just like the problems we did last week with the videos we had last week. And so you can rewatch those videos if you would like. All right, well, good luck. I hope this was enough information to get you through this review pack. And I'll be back at you on Wednesday. Bye.